now? We'll see. That broke that up since we're going into chapter 2. Yes. Let me say this about significant figure and decimal place. It's another thing that often is said incorrectly, and we often don't get enough time to do. In fact, I would even say I could have gone further and taken more time. Number one most important thing is to have a little introduction and have a sense. And usually in a physics class, you at least want people to not do a calculation on their calculator around here somewhere, and then write out the answer, 19.328734 seconds or meters or whatever. Meters per second, whatever. Because you don't know, you can't know that. Well, let's do meters. Well, a meter is 100 centimeters. So 19 meters is 19 times 100, or 1,900. So if I go 1932.8734 centimeters. It's a lot more. 19 big things is 1,900 pinky tips. A meter is like that far, an arm and a head. Centimeters, a pinky tip. It's a lot of them. Okay. So saying I know some length, say to within 1 centimeter, that's within a pinky tip. It depends on your instrument. To say I know it to within 1/10 of a centimeter, that's a millimeter. And with our meter sticks, if you're measuring it carefully, maybe you can get that. But you can't do better than that with a standard ruler or meter stick. This says I know it to within 100th. So I take that little guy and divide it 10 more. You need a special instrument called a caliper, a digital caliper, or vernier caliper. You can do it with some things. But if you don't use that instrument, you don't know that. You'd have to round that up to 9. You'd have to have a micrometer. I mean, this starts getting silly. Like, really, you know that to that well? This is all really fuzzy business, and you don't know what it is. It's too fuzzy. You might not know what that is. So don't write that if you can't justify it. In a physics class, we just want you to be reasonable, usually. Now, sometimes in a lab, people can be picky. It can be pretty tedious, though, I'll say. So I know that I just am not super picky about it. If it's reasonable, I'm happy. If you're not writing that out, if that was a 7, I'd turn that into a 9. Or maybe make it just 3 and not write anything. So let me do an example is good. It's kind of confusing. So what I would say with this, unless you do it over and over, you're probably not going to remember all these rules. When you need to, if you need to for a class and you need to remember the rules or whatever, just go back to them and then. So this would be a first pass where you've seen them, but you didn't fully get it. That's fine. I mean, really, that's fine. So don't obsess, and that's an important thing to know. Like, how much do I have to worry about this? Because it's a little tricky. I've got an example in my head that I think I can do. So do it and then just let it go. And and that's fine. Because it is, it's kind of confusing. Mostly because we don't give you enough time to work with it. Let's take two numbers. Let's do this. 1, 2, and 3. Okay. Sig Fig, SF. Oh, I used A's colors for San Francisco. Oh, well. Sig, Fig. I like them both. And decimal places. Now we're going to worry about decimal places when we add and subtract. Maybe I should have flipped it. Doesn't matter. And we're going to use Sig Fig when we multiply and divide. Again, don't hyper worry about this. Now in some fields, though, this becomes critical if you're doing really precision stuff. If you're a contractor, you don't need to worry too much about this, but you do have a sense. It depends. Let's take a couple of numbers. 3.01. And I'll put units with it because we don't want naked numbers. 3.01 meters, 3 long steps. That's got 3 sig figs. And the last decimal place is blank, blank, blank. There. Goes out to the hundredths place. Okay. Now I take another number. Oops, forgot to color code it. Oh well. And can't help it. Obsessive. Okay, so another number. Let's take 0.020 meters. This is an interesting number. You know how many sig figs that is?
Is it 2?
That's right. There's one way to always know that is if you write it into some power of 10 or scientific notation, which you should be interested. But the rules are not strict. You don't always have to. No one always uses scientific notation. Scientific notation means some number less than 10 and more than 1, or 1 or more, times 10 to something. So this would be 2. Now watch, I'm going to write something wrong. Times 10 to the, let's see, 1 to -2 meters. And how many sig figs are out here? Is how many sig figs. And I go, wait, well, that's only 1 sig fig. This is wrong. These are not equal in the real world, in the working world. Because this is known. I wrote that 0 because I'm saying I know that. So then you got to put 0.0. That's money. That's real work. And again, sometimes you don't care. You just know based on the work you're doing. But sometimes all the difference is in whether or not you do that. Now I see, yes, I've got 1, 2 sig figs. And the last place, oh, gosh, so bad. Blank, point, blank, blank. Gotta do my color. And this one is blank, point, blank, blank. Oops. Blank, point, blank, blank. This is blank, point, blank, blank, blank. Like I'm swearing or something. So you know this one way out of you must have used another instrument, some other better instrument than this one. Because this is when you now, what this is saying is that the last one is fuzzy. It could be maybe one more or one less. Maybe that's 2, maybe that's a 0. Maybe that goes down to 1, 9, and maybe that goes up to 2, 1. This one's fuzzy. If I add or subtract these numbers, if this one's fuzzy in the point blank blank, if it was fuzzy there, it's going to make that one fuzzy. Because when you add fuzz to clear, you get fuzz. So when I do decimal places and I add and subtract, that one is going to, my answer is going to be blank, point, blank, and then the fuzzy meters. In other words, let's do it. 3.01 meters plus 0.00, oops, 0.20 meters. Well, this, you know, again, if you think like high school in kind of that transition or just a class, you know, whatever, it's 3.03. But do you put the 0 there? No, because that's fuzzy, but this one's fuzzy too. And this one's fuzzy too. The last one's always fuzzy. Oops, sorry. That one's clear. But when I do that, this one's fuzzy. And if you don't know that one, forget about that one. If I subtract, now it's messed. Now how do I do this? Subtract 0.02. Now, what I could do is go to my calculator, but again, when you go to your calculator, then you got to worry about it. And not on an exam, but you guys probably know you have a calculator right here on your phone, right? So you just go like, let me just, I mean, it's good to do stuff in your head too, but let's just say 3.01 minus 0.02, the calculator isn't good. I get 2.99, right? So of course that's what I would get. And I go 2.9, and that's good. This is good. I'm going to show you something now. If this number was 0, I'd have to include that 0. Because I got to say to whomever's working with this number how well they know that number, how much you can trust that number. So that's a little bit of care. Adding and subtracting. It's the one that's least well known. This one's more well known because I go out to here. This one's least well known out to there. Now, multiplying. Well, I can multiply these together. You know, it's just 2 times that, so that's pretty 6.02. It's easier to multiply this And I'd say, okay, I multiply 2 times that. You can do it on a calculator with 6.02 times 10 to the negative 2. So I'm multiplying these meters. But wait, this one's good to 3 sig figs. This one's only good to 2. So I can't write, I would write down an intermediate step because it's always good to have more information written down, not too much. So I would write my answer is not 6, but 6.0 times 10 to the negative 2 meters, or if I wanted to, 6.0, 1, 2, boom, 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 boom. That is the correct answer when I multiply those two numbers. Sig figs. So to dividing, whichever has the least number of sig figs, that's the one that's going to determine the sig fig of your answer. And in this case, that has 2 sig figs here, or written that way, 2 sig figs. Sig figs for multiplying, dividing, decimal place for adding, subtracting. Oftentimes I see in way too many courses, they just say sig figs, sig figs. Like, no, not if you're adding and subtracting. That may not be entirely transparent. That's fine. If you ever need to really think hard about it, then you will, and then you'll reinforce it with use. Otherwise, that's pretty good. Just play with it a little bit and let it go, move on. Is that okay?
Yep, thank you.
Cool. All right. Yeah, but definitely keep on moving forward, like I say. It's a lot of stuff I learned and learned well and don't use anymore, and I forgot. But I can learn it faster now, as will you, if you need it. So that's okay. It used to be frustrating, like, man, and I got friends say, man, I learned all that quantum mechanics or whatever, and I don't remember any of it. Actually, you don't have it at the, right there, but you can go back and refresh much faster than when you first learned it. So who knows what you'll use out of all this. But this is the methods of science, or any applied science. This can be critical. Forensics, this can be critical. It can be really critical. A lot of kind of exciting stuff happened in here. With astronomy, like, how well do you know? Like, okay, universe started in Big Bang, as best we know. There's lots of evidence, but it doesn't mean we have absolute certainty. 14 billion years ago. That's pretty good. I mean, the fact that you could say it's not 13 and it's not, or it's somewhere between 13 and 15, that's amazing, right? But really, we'd say 13.8 or 13.7 or 13, that's even better known. But we'll see when we keep measuring and finding out, right? Maybe we'll, so astronomy, it's amazing. Always amazed me, just how much we ballpark some of these calculations, and yet you come up with an understanding that's pretty profound. So cool stuff. Chapter 2, you could maybe move through. It's maybe not conceptually challenging, but worth running through the exercises. It'll give you a super good foundation. And then chapter 3, game on, and chapter 4, totally game on, full on, and then 5.